Hello everyone, welcome back to the video. So today we are going to see problem number 2438, range product queries of power. So let's read the problem first and try to understand. Given a positive integer n, there exists a zero indexed array called powers, composed of the minimum number of powers of 2 that sum to n. The array is sorted in non-decreasing order and there is only one way to form that array. Okay, so they are telling that for the n, we can make a power array which consists of only power of 2's and they are sorted. And the best thing is there is only one way to create it. Let's go to the next part. You are also given a zero index 2D integer array queries where queries of I, left of I, right of I, and each query is represented a query where you have to find product of all the power of j. So power of j. Okay. So for all these queries range, we have to find the product in the powers, whatever the power array we have, right? So for that range, the query, we will find the product and return it. Okay, what we are telling, return an array answer equal in length to queries, where answer of I is the answer to the query of I. Okay. And since the answer of I query may be too long, each answer of should be written modulo of 10 raised to 9 plus 7. Okay, let's try to understand with this example. Okay, they have given n equal to 15. Okay, and these are queries they are given. So for 15, they have explained and showed the power. So we'll write n equal to 15. Okay, and we will see the power array 1, 2, 4, 8. This is the power array. And if we see if the sum 8 plus 4 plus 2 plus 1 equal to 15. So the sum is 15. In this way, we have to create the power array. Okay, and for every query, so it's from 0 to 1. So here it will be 0, 1, 2, 3. So 0 to 1 means 2 into 1. So 2 into 1, it will be 2 only. Okay, then comes the next query 2, 2. 2, 2 will be 4 only, nothing else will be there in that. And then comes 0 to 3, 0 to 3, the whole thing. So 8 into 4 into 2. So 8 into 4 into 2, and that will give us 64. And the return type, as it is shown, it is an integer array, so we'll compute all this integer answer and we'll return it like 2 comma 4 comma 64. So in this way we have to make it, and in this way we are going to solve the problem. So let's try to find how to make a power array first, because it's not given. Okay, so for 15, let's see. Okay, so if you notice the power array of 15 that is given in the explanation 1, 2, 4, 8. Okay, so and you see this is the binary bits of binary representation. So we'll just write it 1, 2, 4, 8, and 16. Okay, so if we write like this 1, 1, 1, 1, so this computes to 15, correct? So let's take another number like 2 we take. Okay, so for 2 it will be only 2, correct? Let's take 6. 6 will be 1 and 1, other things will be 0 itself. So we'll see this power array is nothing but the binary bit representation, like whichever bit is set, we will just add that bit in the array. So we get it clear like how to make it. Let's take another example like 17 we will take, and for 17 we'll write 16 and 1, only these two bits are set. Okay, so for 17 the binary array or the power array will be 1 comma 16. Okay, 1 comma 16. So this will be, we got it like how to make the power array. Now the next thing is just we'll iterate through the queries and we'll do a for loop from I query of I to query of j, and we'll find the product and store it into the answer. So it's simple. So let's do it. Okay, so first we'll making a integer list of integer p for power, new array list. Okay, then we will be computing for it. For I equal to 0, I should be less than 30. We'll be traveling through all the bits. Okay, if that bit is set and sorry and one shift I, if that bit is set, we will add in the p dot add one shift I. So if this bit is set here, okay, so when we're traveling, initially it will be one, left shift 0, it will be 1 only, correct? So if that bit is set, we will add into it, and here our power array will be ready. Okay, then we will create an answer. This will be our answer, new int, and its length will be queries dot length, because it's same of the queries, correct? Okay, next we are going to next we are going to iterate for every query and calculate the product. So for int I equal to 0, I should be less than queries dot length I plus plus. Okay, um, int current. Okay, it can exceed. So okay, int current equal to 1, and for okay, we need to find the queries first. Int start equal to queries of I and 0. This is the starting, and int end equal to, this is the ending of our range. That will be 1. Okay, then comes we will int j equal to st. We will iterate through a loop. J should be less than equal to end. Right? We are including the end also. And we'll do current equal to current into, we have to do a modulo also, correct? Into p of p dot get j, the power array, correct? And modulo of mod, and just declare a mod here. Int mod equal to 1 2 3 4 and so on. Yeah, 10 raised to 9 plus 7. I think I've written correct. Okay, then here it will be current p dot get mod. Okay, and then answer of I equal to current. We'll just add it here, and we will in the last step return answer. So it's simple. Okay, we get an error. Mm, Oh, we have not written anything. We have to write like not equal to 0, because when the AND value will be not equal to 0, mean that bit will be set. Okay, we have to put this into the bracket, the Java constraints. Okay, here we go. We're getting the answer. Okay, we're getting one wrong answer. I don't know why. Need to look into it. Okay, here we're getting a minus and 147. Okay, the answer is correct. We're just getting a minus. I need to check why we're getting it. Okay, so I think we're getting because of this int and the number is overflowing, so we'll just make this long. Okay, and while hiding we will do this conversion, we'll pass it into int. Let's try if it works now. Yeah, it's working. Let's try to submit our code and see how it is working. Does it pass all the test cases? Yes, it passes. So nice. Okay, so from this you must be thinking like the solution is pretty simple. We are iterating, and here the time complexity will be like we are doing a n square here. We are using a double loop. Okay, but we are just iterating log of n. So it will be for every query we are iterating log of n, because this is a the power array is our binary representation. So whenever we move through it, it will be only 32 bits and it will be a log of n, q into log of n. For every query we are doing a log of n work. And talking about the time complexity, it will also be log of n because we are storing the bits into the integer list. Yeah, so thinking about it, we can also pre-compute. We can use prefix sum here for calculating the queries. So let me show you how. I'll just remove this code. Okay, and we'll go to the board first. Okay. So here we can see like 1, 2, 4, 8. Correct. So we can just make an prefix product array like 1, 2, 4 2s are 8, and 8 8s are 64. And suppose for query 0 to 2. Okay, for this query I'll just mark 0 1 2 3. Okay, so 0 to 2 it will be 8. Okay, how we get it? We'll get it like we are, this is product prefix array. Okay, so prefix of end, end. Okay, minus sorry, divide prefix of start minus 1, start minus 1. Okay, so here start minus 1, start is 0 only, so it will be minus 1, that is out of bound. So in that case we'll directly return this. Okay, but suppose we'll take another query like 1 2 3. Okay, 1 2 3 we are taking. What is 3? 3 is 64. 64 divided by what is the start minus 1? 1, so it will be 64 only. So let's take another query, another example from this only. Let's take 2 2 3. Okay, so 2 2 3 will be like 3 will be 64 again. 64 divided by, but here the start point is 2 and minus 1 will be 1, so divide by 2, so it will be 32. So if we do 4 8s, we'll get 32. So in this way we are getting range. Okay, I'll just erase this. But there is a point, this we can only do for plain arithmetic equations where we are not including modulo in that. But when we include the modulo, we cannot do this and will not get the answer, will not get the correct answer for that. So for this we can make a 2D array. Okay, we can make a 2D array and then store all the products, means pre-calculate the products in that. So because modulo is involved, a normal one, so we'll make a 2D array and do a pre-computation like prefix multiplication we can say, and I will show you how to construct that 2D array and how we'll get the range answer. So initially it's a 4 by 4, the length of this power array. Okay, this is power array, our power array. Okay, so initially we'll start with I equal to 0 and j will iterate. Okay, so it will be 1, it will be 2 into 1, that is 2, then it will be 2 into 4, 8, and 8 into 8, 64. Okay, Then from the next thing, we'll keep this as 0 only. We will directly start j from, means I will shift to 1 and j from 1 only. So it will be 2, 8 and 64. Okay. Then again we'll keep this 2 as 0. We'll not go into this. And we'll be calculating this 4. Okay. And 4 8s are 32. Okay. Then again we'll keeping this all 0 and this will be only 8. So in this way our array is ready. Okay, pre-computed. Now we'll see queries. Okay, again we'll see queries. So from 0 to 3, suppose we took 0 to 3 all. So 0, this is a 0 and this is a 3. What is the value? 64. Directly we can return 64. Okay, then okay, next take we'll take 1 and 3. So for 1 and 3 it is also again 64. Now this is 1 and this is again 3, so it will be 64. So let's take 2 3, 2 and 3. So we'll go to the second row, that is this, and we'll take the third value, that is 32. 32. And if we check if it's correct or not, so 2 is this, 4 into 8. 4 8s are 32. Yeah. So let's make an array first. That is, let's give name result and we'll take an integer array. Okay. To new int. Let's take a variable first. Int len equal to p dot size. Okay, len comma len. Okay, then we'll do iteration to this res. Int I equal to 0. I should be, this you all know, right? Okay, let's take a long current how we took in the previous solution, correct, as 1. Then for, we'll start j with I. Okay, then we'll doing current equal to current into p dot get j. Sorry, get j. Okay, but we have to also do the modulo, so we have to put in the brackets and modulo mod. Okay, we get it, and we will be adding for every j like rest of I j equal to current. So we're done with this. Okay, so now we'll be computing the answer array again. So we'll be iterating again through every query, like int st equal to, sorry, queries of I and 0, that will be our start, and int end will be with a 1, correct. And in answer of I, as I shown you in the explanation on my board, right? So we'll be directly giving rest of start and end and returning the answer. So hope this is clear. We'll just run the code and see if it's working correctly. Okay, we need to convert this. We need to typecast it to int because it's long here. Okay, it's working. Let's try to submit it. Okay, that also worked. So in this, we don't need to iterate for every range. We are just giving in big of one time. For this pre-computation, we are requiring log of n square time. So that's the only thing. And here time complexity will be log of n, log square n, sorry. and the space complexity will be log square n, because we are storing the bits like the 32 bits like log n into a 2D array. So thank you for watching the video. Hope you liked it. If you have any doubt, please comment and I will try to help you. Yeah, thank you.